Well, hi and welcome to my shop this morning. So I'm going to be taking on these two electronically identical radios, just like I did the last two Baby Champ radios. These ones, in fact, are called Champs. So this is a larger version of those two small radios that I spent so much time working on. So now these ones I've already restored. You may recall watching videos as I restored these, but I never put the two of them on my bench at the same time or did anything like that, although it was in the back of my mind back then. And here it is now. So I think the first step here, first couple steps, compare the schematic of these radios to the Baby Champ. See if there's any significant differences. Maybe they're entirely different, or maybe they're almost identical, in fact, electronically. These are 5-tube radios. They can't be that much different, really. And play them just as they are and find out, gee, did I make them work or not when they were in my shop last time? And then get them out of the cabinets, onto the bench, and start some comparative testing. I think I'd like to do that voltage testing that revealed so much in the last two radios. And then from there, it's just fiddling around with the alignment and things like that, unless I find more components or maybe resistors in here that need to be changed that I managed to not do last time around. So let's start by playing these right away and see what they sound like. I think it's on. And here it goes. Oh baby. One of these I changed the volume control, and it could be this one, and the volume control may no longer be. It's kind of an all or nothing radio at this point.
Exactly, and today it's the first piece of technology they go after in the crime scene. So let's just say
there's that motorboat sound that's so common in my shop. So that's 590, and it's in the correct place. There, we can null out that noise. That's a lot better. Now we'll see about the French station up here.
Et donc, justement, c'est porte-parole de ces prix-là pour la 5e année.
Donc, c'est ça, mais pendant des années, moi, j'ai fait ma petite affaire.
Puis, tu voulais pas être associé nécessairement.
Wow, lots of volume in this radio. Okay, so there you are. Working. Where's the off switch here? No off switch. Working. Pretty typical of an AM radio in my shop. That's pretty typical there. Okay, other guy. Uh-oh, what's going on here? Oh! Yeah, so well, there's something we'll have to fix inside this radio. Instead of it having a string, it has a tie wrap. It's actually got a tie wrap on here. And I guess the tie wrap plastic is, settled in this curve. It's not a string, right? It doesn't want to release from the curve. I'm going to help it here. Okay, right to the French station. Very good. $7.40.
Down to one lane near Thompson and eastbound O'Connor right lane blocked at St. Clair. The school by dining is your destination for fresh.
I'm going to have to replace the string, obviously. So I think this guy's working a little better than the other one. Getting the 740 station. I didn't hear that on the other radio. So let's go to the next step, which is to take a look at the schematics for these two Champ radios and compare them side by side with a Baby Champ and see if we're dealing with the same radio or not. We have exactly the same notes here, same impedance, but the diagrams are virtually identical. Even this 170 that you wrote in here, well, that's really, really identical. Red, blue, red, green. Okay, it's not perfectly identical. We'll take a look at the output tube. This is a 50L6, and over here I think it's a 35L6. Interestingly enough, one of the radios said you could replace the 35 with a 50. Here's a 50, but in this radio, to do that, there's this resistor 39 here, just in the heater string. And what have they done over here? I'd say the resistor's missing. You take out the resistor and put in a 50L6. You have to take out this resistor. Okay, so that's a little difference. We'll look at the cathode resistor and bypass. Pretty sure that's it there. At a glance, these are very, very similar radios, of course. They can't be that much different. Okay, looking at the detector tube. Looking at the wrong tube here. Here we are. Drawing exactly the same. 42 volts. 56 volts, less voltage, interestingly enough. Here, can you see that? That's just a shield connected to the chassis. Here, both diodes joined. That's really, really similar. Signal comes out, R7. Part 13. R7 bypassed, R13 bypassed by 25. It's the same sort of deal. And then there's a input plug on the back, a phono plug. And if you use the right kind of phono plug, it's one with a very long prong. This works as a switch. And when you push it in, it'll cut off the radio output and just have this as the input to the amplifier. But this radio doesn't have that feature. This one has this capacitor here. No such capacitor on this radio. It's just minor differences, I think. They look very, very similar, in fact. So we come here, the IF tube has a cathode resistor, and here it is here. quite see how the connections are made here, but I think once again this is going to be very, very similar, but not absolutely identical in how this is done. They're not identical radios. Come down here. Okay, let's look at how they did the oscillator. So this radio, this is the Champ, has a transformer. And this radio uses an auto transformer to do the same thing. Right here, this guy has the two trimmers in parallel, and so does this one. I never got that in my head clearly when I did these radios. I wonder. Up here's a single trimmer capacitor through simple antenna with terminal, a capacitor protecting it. Single antenna with terminal, there's no capacitor protecting this terminal. How do they get away with that? I don't know. You're straight. I don't know. Okay. Very, very similar radios, for sure. Just look at how the heaters are done, just to be sure. So there's an order to these, which is picked at, somebody has to pick the order, so there is an optimum order to wiring these tubes. So 35, SA, SK, SQ. 50, SA, SK, SQ. Same order, of course. No surprise there. Okay, and the power supply filter. Same basic deal. Couple of resistors. It's just drawn differently. Yeah, you know what? These radios are really, really identical, but not quite. Very, very similar. But then again, I think almost every 5-tube radio you can do this with, and they're really very, very similar. So let's get these radios out on the bench now. Okay, they're both out of the cabinet. This one came from the wood cabinet. So what is the difference between these radios? And there can very easily be nothing, really. These could be perfectly identical examples. This is the Northern Electric Champ model 5200. The other radios were model 5000. So I'm looking them over here. I'm just glancing back and forth and seeing really wow, so the red wires here, it's been cut off of this radio. That's not much of a difference. There's the if you can see it, there's the tie wrap technique for connecting this, which I'll put a string there. Fix that. So just looking at the wiring here, it's all very, very, very similar. Funny how they made these radios. They had to put these brackets on this cockeyed angle to come up here. It's just not something you don't commonly see apart. Kind of just whipped in there like that. Usually everything's kind of right angles. See, this can is up on an insulator. This one is not. Same thing on this radio, of course. Okay, looks like I put one of my tubes in when I was doing work on here and left the number in. They look identical. I don't see anything here to jump up about. The antennas are very, very identical too. Number on them, B823423. Maybe it's R823423, same number. Okay, let's look underneath now. We'll see what we've got going underneath. Okay, there they are. Now, right away, notice something different about these two radios from the last two radios, and that's how the cord was done. Assuming these are original cords, I suspect they may be. There's a knot on either side, and here they have a grommet. On the other radios, they'd installed a short green plastic tube over the wire here between the knots. They hadn't put a grommet in, so they graduated to putting grommets in. So I guess baby Champ, tube. Real Champ, real grommet. Yeah. See, this one's done the same sort of way. You can even see when you look at this. If you follow this wire, you see that little bump there? And look at this one. Same funny bump there. I wonder if the same person did this in exactly the same way. And the answer is no. Why? What has he done here? So this is me over here fooling around. Oh, that's right. Yeah, the switch is missing in this radio. Yeah. So this radio, when it's plugged in, it's on. I should put a note on it somewhere. Always on. And this is the one with the, I couldn't find an appropriate volume control. We've ended up with something that's just too fast on this radio. Okay. There's a red wire cut free here and hanging. And there's the replacements over here. So this wire should have been cut out and removed. This is somebody else's work here. This is my work here. I replaced this high wattage resistor. It's left in here. The old capacitor's cut completely clear. Part of this one still relied on. The bypass part, I believe, is being relied on here. So I left this capacitor in. This is capacitor to this input on the back. I changed the one over here. The yellow wires now, everything looks a lot cleaner on this side. The chassis looks new. It's like one of those other radios. One chassis looked like, oh, almost brand new. This one's got more mileage on it, or dirt in it anyway. But that's not a significant thing. No, they look very, very identical. I'm not finding anything here that's jumping out and saying, look out. Good. So one of the things about 5-tube radios, including these, is that there can be a voltage, and it could be dangerous, on the chassis relative to grounded things in your house or wherever. There's a danger to these 5-tube radios that don't have a transformer. A curious danger, a little tricky to understand if you're new to all this stuff. So hot chassis is the issue. You can look up on the internet lots of information about that, and it's tricky to fully understand it, to get the full picture of what's going on there. So, and if you don't, then in a situation like this, unusual situation, having two pieces of equipment on my bench, it's easy to have 120 volts between these chassis, and I don't want to touch that. So that's the first issue, is resolving that, and it has to do with the way in which these get plugged in. I'm just looking for my I just had it in my hand a second ago. I have a plug splitter, plug expander. There it is. So I'm going to plug these into this old non-polarized plug expander. Okay, I'm going to plug this into my supply. Again, if you're new to my videos, there are safety things I am doing. I'm not explaining in detail. To keep myself safe, I just say to you, the primary rule is know what you got and what you're doing and how it all works, and use your voltmeter, just like I'm about to do, to prove things out. So I have the two radios plugged in, but I don't know if I've done it in such a way that this dangerous voltage is going to appear. So we're going to find out. So I'm going to make sure these are turned off. Unfortunately, I cannot turn this one off. So this one's going to come on. This one I'll keep off for now. Apply some power. So you keep your eye on the voltmeter there, and we'll see what is between these first chassis. Dun, da, da, da. Well, that would be kill you, potentially kill you, maybe not. If you actually touch that, you may not be able to draw enough current to actually get electrocuted. I'm pretty sure you would feel it, and we're not going to find out, on purpose anyway. And now this is between two B- points in the radio. I should see exactly the same thing. Pretty well, yeah. Just okay. Now I'm going to flip one plug. flip the radio that's not working. I made absolutely sure there was no contacts between these radios before I did this, by the way. Now we'll look and we'll probably see the voltage has gone to 0. 0. Now to prevent me from boobing up, I'll leave these two radios plugged together in this unit. If I do unplug one of the radios, then I'll have to go through this process again to make sure things are safe. The next thing I want to do is I want to join the B- points together on these two radios for make testing easier. Okay, and I'm gonna be suspicious of my clip leads. One radio is operating, one radio is not. Why don't we just shut the power off while I do this? So I'm going to clip this onto a B- point where it won't wander. That's good. And then a similar point over here where I can safely clip it. Won't wander. Right on here. So now I can take the ground clip or neutral clip or reference clip, whatever you want to call it, and I can clip it also onto the B- of either radio. And I'm going to pick this point here and see if I can get the clip to stay steady. I don't know. That won't be touched, that should be okay. It's really loose. Okay, that's good. Okay, let's get going. So just to remind everybody, these two radios are essentially worthless radios. Cabinets are terrible. There's a lot of these around. I've already put too much money into them as it is. So this is all about fun and education and messing around, and it's all about me having a good time in my shop. Not so much about making these radios work, beautifully and all. They're just never going to get there. So, okay, having said that, let's carry on. Let's see, we're going to set the voltmeter here to 150, and we're going to check the B+. Oh, I've got to turn them on. We're not going to get anywhere like this. Okay, so I have the B- bond wire in, dim bulbs on. Again, it's a dim bulb. If you don't know what I'm talking about and you're doing this kind of stuff, find out what a dim bulb system's all about. It's very, very, very useful in a shop like this. I really like it. Okay, so dim bulbs are saying nothing's wrong. So we now have full voltage on these radios, 124 volts today. Okay, let's check the B+. We'll start on this one. Here's one side. So on the 150 volt scale, that's just under 120 volts. On the other side of the power supply, 132 or so, something like that. You can probably read it better on the screen than I can from here. So 120, 130. 120 is 130. Okay, now this radio, needs to be turned on. Oh, okay. So, anybody see what happened there? I made a boo-boo. I made a big boo-boo. The thing about, and I know better than this, the thing about these radios with the hot chassis is If you have the switch set, let's say on, you get one kind of result. If you turn the switch off, you get another kind of result. If you reverse the plug, you get the reverse result. So offhand, there's no way to know what's going to happen with these radios, just offhand. And you could have it this turned off or on, make a test like I did and go, hey, that's great. And then come along and switch the switch. And it ain't so great anymore. So the flash you saw, if you saw it, was the fuse blowing in my... I actually have a protective fuse right in here. Just for these moments of mistakes. These moments of mistakes. And I should know better. Okay, first thing, we're going to cut the power. I'm going to replace the fuse. It's all, I don't know if you can see that or not, but the wire is fried against the inside of the glass now. Phew. Here's a look at that fuse. You can see the fuse elements, just little blobs of molten metal. I probably just fell. Just kind of fell onto that surface there. Yeah, that's a really blown fuse there. Okay, let's try this again and see if we can avoid blowing the fuse. So I've disconnected the bond. There's no connections between these radios. They're still plugged in exactly the same way they were. Again, I'll power them on. This one's going to come on because he has no choice. They must both be switched on right now. Yeah, I probably switched this on and left it. Okay, what's the story? So watching this meter. Oh, diggity dog. So 98 is full voltage because I've got a dim bulb in the circuit, so the voltage has dropped a little bit. So the whole shebang is there, which is what blew the fuse. Now if I turn this off, being very careful, I touch only one thing, and now I look for it. Ah, not there. I could turn this one off, but I can't. So I'm going to reverse one plug. I'm bearing in mind I'm leaning right over these guys now. Okay, now it's in backwards, or the other way I should say. Now we'll look for the voltage. Now it's there. Now we're going to turn this radio on. And now it's gone. So this is the deal with these radios, is on and off. It in a weird way reverses the problem. It's not really reversing the problem, but you think you've gotten rid of the danger voltage. You switch the radio off, because how could switching it off ever make it come live? And it comes live when you switch it off. So read up. If you're fooling around with 5-tube radios, you might think 5-tube radios are safer than the great big shortwave radios. In one sense, they're not. In another sense, they are, because the voltages developed in these aren't that high. In the other big radios, the voltages are much higher. So now the question is, do I dare? If I connect, let's think about this now. How did I get away with this with the other radios? If I connect the B minuses together and then switch off this radio, see, right now it's a big 0. And then if I should switch this off, they're not connected. It's there. There it is. Zingo. Why, this just seems a little different than the other radios, which I was switching on and off at will. Wasn't I? Okay, let's remember where we're at. Just so I don't forget. Okay, we're in the danger zone. So we're going to switch this guy on. So the rule is, at all times, have this radio on. This one's always on anyway. Or if I'm going to have this one off for a length of time, I either have to switch the plug here to remove the voltage or pull the plug right out. That'd be a smarter move. Okay, I'm just a little serious about this because you saw me pop that fuse unexpectedly. I could electrocute myself unexpectedly just as easily. I think we're doing one more check. One more check before I actually hook these up. B minus to B minus. Nothing. Okay. I'm really not sure why this was a different deal. Did I just never actually switch the other radios to cause this problem? Can't imagine that. Boom! No boom. Okay, we made it. We made it. Oh my gosh. Both radios are operating. We're ready to go here. Ready to go. Let's just zoom right in on this meter. Okay, 150 volt scale at B plus. So I'm measuring it over here first. Oh, we're on dim bulbs. Okay, off dim bulb. So this way in my shop, when the dim bulbs are out of the circuit, there's not much protection here. So the fuse steps in as the next line of protection. Okay, B plus. So that's just under 120 and just over 130. Just under 120, over 130. And on this radio, just under 120. Just over 130. So same voltages. Okay, so we'll go out now and pick off. Let's try this tube way out here. What kind of voltage is on this tube? Right there. What's that say? It says 68. I'll come over here. 62 or 3. Okay, look here. 62 or 3. Come out here. And just to go to the other, so it was all just under 68. It's pretty much the same. So they each got the same relative on their own tube, but this guy's a little lower. And that could easily be because of some resistor in here. So B plus sounds good. Let's try another tube here. Let's try this one. I'm picking off the B plus terminals just by the color of the wire going to them. So in this case, we're reading 68. I have to look at the manual and see what it says about this. 62 again, just a little lower. It reads 60. Just a little higher all the time. Okay, we'll try, this is the output tube here. 150 volts, that's 35 volts. That sounds like a funny number. 35. About the same. Oh, it's gonna be another. About 40 there. Just a little lower. This is always just a little bit lower. Okay, now we'll take a look at the AVC voltage that's reaching the volume control. So we will try. No AVC voltage, no signal in the radio. I mean, that's not worth doing. So they're all, you know, relatively the same. And what should they be? He says, what should they be? I'm just going to peek at the schematic on my own here. So schematic. So we should see 105 on the output tube and 70. 105 and 70 on the output tube. 105 and 70. That's 115. That's 110. Okay, now the 70. Somewhere in here there's a 70. $65, which would be the 70. There we are. Right here. $65. 110. So good. All these voltages are coming out relatively okay. Okay, like I'm just about ready to start here, so I'm maintaining the B minus to B minus connection. The main reason for that is if I do something wrong here at some point and a shock hazard arises, it's going to pop the fuse and I'll be safe again. If I disconnect this, then I'll become this bond wire at some point. I don't want that to happen. The input point for this test on this radio is onto the antenna gang capacitor. So these red things you see sticking out here are actually 2.1 ohm capacitors clipped in place, and the leads are sticking out. I put these rubber red plastic covers on them just so they don't short. So the next thing we need to do is make a connection to the oscilloscope, and I'm going to do this on the diode output past the isolating resistor. I know what I'm doing. And that's the same as hooking up to the volume control terminal here. This will do. I think I'll save that until it's time to do it. Just need to hook up the negative. I think I'm going to do that now. Think a little bit. You know what? Before I do that, just because I should be careful, I'm going to read the voltage between this and the radios. There should be no voltage, although my meter may report something. So both radios have to be on here apparently, or I'm going to blow the fuse. I think we're all set for power. Dim bulbs come on really bright with these radios. Can look for voltage now. Well, we're still on the dim bulbs. So between my hydro ground, or just equipment chassis ground, case ground, I guess you can call this all kinds of stuff, hydro neutral, everything you want, what is it to the chassis? So 40 volts. That's okay. This one should say probably the same. 40 volts onto the B minus. Same 40 volts. So that's okay. You might say, what do you mean that's okay? That's 40 volts there. 40 volts with nothing behind it. So I clip this on, the 40 volts goes away. Do I dare do that just like this? I better not, because if something pops, I'm going to jump, and if I jump, I can knock everything over. If I knock everything over, back to square one. So I'm going to put this on now to the B minus, a B minus point. of my choosing. And on to, I'll be ready. It's gonna go right here. It's gonna go right here. We're gonna try it right here. Like that. Perfect. Okay, I'm gonna flip on the power. Okay, nothing bad happened. And I'm gonna let the radios warm up. We only really want to work on one, but so we'll hear that one. I'll not hear this one. Good. We're only hearing this radio. Now a little experiment here. Times 10. Times 1. A small effect. Times 1. Times 10. No effect. There we go. Now this is a sweep coming from the sweep generator. Let me turn down the volume. We don't need so much volume. Now the sweep generator is already sweeping. Did I not connect it? I've not connected it yet. I just realized I'm doing all this with the radios facing the wrong way. Okay, hold on. Now, I tested this before. Should be able to rotate all the way around. Here we are, because I have to get at these screws here. Now, rotate it right back. So I want to make sure I put this ground appropriate here. Somewhere it won't go flying. Okay, and now the input. Okay, I think that's okay. Now we're going to turn up the strength of the input signal. There it is, and you can see it on the scope. Perfect. Now, we're still running on a dim bulb, still running on reduced voltage, 94 volts because both radios are running. We'll pop it up in a minute. Let's check the sweep range here and make sure it's correct. So it should be going, no, it's off. It should be going 405. This is what I picked, 405 to 505. And right in the middle of that is 455. Sweep. Now center the sweep on the scope here. From control. Again, I don't know for sure when I do this that this is really 455 on the center gradual. That's what I'm hoping it is. Maybe it's sitting there. So we're going to have to bring in the other signal generator again. I kind of forgot about that. So we can discover where 455 really exists. Okay. So this guy's got to go on the ground wire too. Getting pretty busy in this radio. Just going on this wire. I'm going to clip this to the same location and probably quiet things down. Compensate by putting a little more in over here. And I'm going to swing this. If I just turn the camera a wee bit, you can read the numbers. Perfect. Oh, that's great. So I'm going to set this now to 455. If you watch the scope display, you should see something. Not that. Not that. Not that one. None of those. Here we come. So to make this work, what I'm trying to do, I have to get the output levels kind of balanced between these two signal generators. Let me cut that one back and see if that does the trick. And it's just disappeared. So I'm going to go up on this. We're going to raise this other one a little more. Cut the volume. No. Cut the volume. Okay. I think we're in good shape now. It's still doing that. Just too much coming out of this one. Turn it back. Okay, that's going to work. So now, if you watch, the other signal generator's signal is out here somewhere, and it's having no effect on anything. As I bring it in, the radio will begin. When I say amplifying it, it'll begin showing up on the trace here, and when I get the wiggly funniness to end up right at the bottom of the valley, then we can read the frequency of the valley here. And hopefully it's 455, or on my machine it should be 453 or 54, because it's a little off calibration. So I'm just going to watch the scope, find out. Here we go. Okay, so right here, I would say that's the magic spot right there. And the number is 454. So it's bang on. I'm going to put it on full power here. Shouldn't change anything. So this is telling me this radio is at 455. I'm going to move this point. I'm going to use the scope control to move the point in the middle, just so I don't have to go hunting for it again. So now we know anything on the center gradual is 455. Okay, I'm going to move this one away. And now I'm going to fiddle with the IF transformer, which shouldn't do anything because I aligned this radio already. Okay, let's swing it around. Oh no, there's no swinging it around now. My shop arrangement has kind of gone sour here. So we don't need the frequency. We don't need this. Get rid of this one. Okay, we can go around. There we go. And we can turn that down a bit. Okay, that looks great. It's a great looking curve there. Let's see if I can mess it up. Turn it into something. Try this. That's a lot better. Okay, watching the display. Okay, again on the display. So making very subtle changes to the shape of it, which might have a not so subtle change to the sound quality of the radio. Like if you can tighten this up too much, you know, you can't really hear this. This is too quiet down here where it's really wide. So you have a wide frequency response, but it's down here too low. It's up here where you're really interested in the frequency response, I'd say. And so you want it to come out and capture enough of the highs up here. You know, without like, you really should be listening to this to really, you know, listening to music or something. Yeah, you're supposed to max these guys, so that's what I'm going to do. And this is not a high fidelity receiver. Is there such a thing as a AM high fidelity? So this is all fine. I can't remember. Maybe I used the sweep on this when I did it the first time through. Okay, now for comparison purposes, let me move this guy up onto the center line. With the current signal being fed into this radio, if I don't change sweep signal, the IF is producing this voltage here. That's 1, 2.5. 2.5. I'll write it down, Jim. 2.5. 2.5. So now we're going to transfer our attention over to the other radio. This should be easy if I've done my job right here. So first the signal. Off that guy. Turn him down. Turn this guy up. Oh boy, that's a fast volume control there, man. Wow. Yeah, I'm gonna have to think about doing something else with this volume control. I think I worked hard to get this one in here. Do a lot of work. Okay, we'll go up here. There we have similar sound. That's a good start. Now we move the scope. Okay. First. Right here. We'll take this ground off. This is where you get a shock doing this stuff. I get a shock. You don't. You don't get a shock. You're safe at home there. Onto the ground terminal. A ground terminal. Right out here. Going right out here. Is that right? That's right. Way out here. And then onto the volume control here. There we have it on the screen. All signals the same. And what do we get? This guy gives us 1, 2, 2, and a bit more. It's a little ahead in the game. So, you know, that can easily be because of vacuum tubes. Vacuum tube differences. I think, anyway. Okay, now we'll just check it. There we go. Okay, watching. This looks like it's just a little bit bent to the right to me. Oh, it's not in the middle. Oh, wait a minute. This isn't on 455. There, let's check that. Let's just check that because things are drifting. Okay, so I'm going to bring this around again, slow and steady. I can actually put this down like this. Come around a little further, a little further. Okay, and we want to put this on the B minus. We can do it right here. And then this onto the input. Knock it down. It's okay. Now we'll dial this guy around and find out. Where is that bump? Right there. frequency, well, it's pretty darn close. So I would have to say the settings on my sweep generator have probably drifted. Let's check. Yeah, it's supposed to be 405. It's 398, 405. It's good. And then the stop, it's also drifted. To come in and turn this equipment on a couple hours before I use it. There we go. Now, what's that look like? Well, see, now it's almost in the dead center. Right? And again, this is probably just, if I just touch these controls a little wee bit, it's going to jump around. There, right there. Yeah. So, good. It's 455 enough. Back to the shape. And if I take this off, we'll get back to the full strength here. Easy, easy, easy. Careful, man. Come on. Yeah, so to me, this is coming across on this angle, and this side is coming almost straight down. It doesn't looks like this should be kind of moved over while this stays put. How can you do all that? That's what it looks like. Coming around. Just see if we can just going on there. Gotta use a metal screwdriver. The screws are stiff. I'm going to do something now that may make this look just so different. I've been sweeping with a log. Yeah, I don't know how my sweep generator works, but for some reason when I switch it off log, it has a whole different set of frequencies. I have to readjust it, so I won't. So there we go. Enough muttering. So the story is, both these radios in good shape, everything tuned up fine. No varying voltages between the two of them. No resistors appear to be out of whack. No capacitors left to change in them. So I'm gonna set them down again. Oh no, I have more alignment stuff to do. Man, I almost forgot what my intentions are with these guys. I'm not so worried about the IF. It's the front end. On the Baby Champs, I only went so far with the front end. I could go further. I'm going to go a little further with these two. And really carefully check the front end tuning. So that's the oscillator. And the oscillator and the antenna tuning. I'm going to take a little break right now, though. Okay, I think I got things set up so we're going to be able to align the front end of each of these radios and get it right. So let's just take a look at the SDR. I'll put the SDR right up on the screen here. Okay, so the things that are of interest is this hump or bump and this red line. Now I'm going to tune the radio just a little bit. Great. See both those items move. Okay, let's go back. Okay. Don't need to listen to that. So what are we seeing there? So we're seeing the tuning response curve for the front end of the radio, which is the antenna and the tuning capacitor. And the other line that was moving, the one that's got the red line below it, is the local oscillator frequency. All we got to do is just make sure that those two things are separated by exactly the frequency of the IF, 455 kilohertz. So just taking what's right in front of us right now. The front end response curve is for, let's say, 850. I'm going to do this on a calculator. 850. So that means the local oscillator should be at 455, above that, 1305. So on the screen here, I can move this red line, which is over here, just move it to 1305. Let's see where it ends up. 1305. So that's where the local oscillator should be. Now, to prove to you that that really is a local oscillator, I'm just going to tune the radio a little wee bit. So these are not in alignment. Now we'll just go from one end of the band. We'll check one end of the band here. I do have to put a string on this. Oh. And you know what else? We're gonna gotta load those. And what I'm talking about is the response curve down at this end here, right down to the bottom. By the way, the champs claim to tune from 530 to 1600. The baby champs tune from 540 to 1570, just slightly inside that. Is that why they're called baby champs? I don't know. Strange. Why it would be that way, I have no idea. Maybe that was an unintended consequence when they got the whole thing finished. It didn't quite cover the whole band. I don't know, it's odd. So let's do the calculation here. Front end. Oops, so my excuse me, my SDR display just kind of jumped. Front end is at 530. That's interesting, 530. If we add 455 to that, 985. Okay, so I'll dial up 985 here. 985. And that just puts the red line so it's easy to spot where 985 is. There. Oh, look. I think the local oscillator is right there. Let me wiggle it. Yeah. So lined up good here. Now, we'll go right to the other end. You know what, I'm going to put this full screen on the SDR for you to watch. Slide over that. Okay, continue tuning. That's the end of the range. It's supposed to go to 1600, but the peak here, I would say it's right around there, 1527. The front end's not too interested in 1600, that's for sure. Now, what's the local oscillator doing? So let's just get the frequency of the local oscillator here. I just click here, and it's up there, 2265. So I'm going to grab my calculator, 2265 subtract 455, 1810. Oh my, what's going on? What happened there? Did I do something wrong? 2265. Yeah, 1810. Holy smokes. Holy smokes. That's all I'm going to say about that. Okay. So what I'm going to do now is I'm just going to switch radios here. And I'm doing this whole thing with the, I'm doing this at, that's okay. We're not going to change anything just yet. I'm doing it with the restricted voltage. Oh, very much. 93 volts. Okay, here comes the other radio. Excuse me. Okay, this one is already tuned up. Already tuned up at the end there. At that frequency. At the end, 1600. Is it all the way possible? There. That proves this is the oscillator here. I think it's a much taller signal. Well, that could just be just because of how we've thrown the coil on here. It doesn't mean anything. Okay, so that's 2203. Okay, I'll calculate. 2203 minus 455. It thinks it's tuned to 1748. That's still awfully high. 1748. It's actually, excuse me. Well, I guess, it's a little hard to see. The peak isn't all that great. It's weird when it's got this noise stuff in it. I think it's right around here. Here. 1726. And 1748 or 1750 be here. Not much tuning effect there. Let me tune the radio and just look at that. Oh yeah, you can see it much better now. Yeah, I think when the capacitor stops, the tuning peak is right about here. Right about, I'd say. Right around in there, 1734. The radio's not supposed to tune beyond 1600. And if this is where the front end is tuned, then it would hope the oscillator is at 455 above that. 1734 plus 455. I got some nonsense there. Something went wrong. 1734. Let's try it again. 34 plus 455. It's more like a 2189. 2189. So I'll make this red line go there. Screen jumped. 21. Oh, and this is the problem. I gotta fix this. Whoops. Okay, here we are here. 2189. 2189. So it's a little off, but it's close. It's very close. Okay, so the big name of the game here with these two radios is to make the adjustments necessary to try to get this to fit properly. Oh my gosh. Yeah, that didn't make much sense, did it? Well, I've been at this for a long time, so that's why I'm not making a lot of sense. But I know what I meant. So I think I'm going to call it a video at this point. You can see by the clock on the wall, it's time for dinner. that's what I'm going to go focus on. So thanks a lot for watching, and we're going to pick up with these radios right from this point. And I have this feeling those baby champs are coming back in for this treatment. Okay, so thanks a lot for watching.